Okay, so our two-dimensional problems. Scale drawings work, but are time-consuming to do. So we need to know how to solve 2D questions with our calculations. So to solve our 2D problems where, not where you have vertical motion combined with horizontal motion. So where vectors are perpendicular to each other. You need to draw your vectors tip to tail, as I mentioned earlier, to get a right angled triangle. Then you need to use Pythagorean's theorem to calculate the resultant vector. You can use trigonometry to solve for the angle/direction. Before we start, we are going to just review our trigonometry rules. So the one trick way to remember, as you might have heard of, is SOHCAHTOA. So sine is equal to opposite over hypotenuse. Cos of, and I should put in actually sine theta. Sine theta is equal to opposite over hypotenuse. Cos theta is equal to adjacent over hypotenuse. And tan theta is equal to opposite over adjacent. So this might be something good to write at the top of your page or on another piece of paper, just to remind you of our trigonometry rules. Also, Pythagorean's theorem is a squared plus b squared is equal to c squared. So where this is one side equals your hypotenuse. Remember that c is always the hypotenuse. Okay, so let's do an example to understand how we go about this. So say you're learning to drive a standard. You're not going to go very far on this example. You drive 165 meters south, and then you turn and drive 214 meters east before you decide you've had enough for one day. This whole learning excursion took you a total time of 2 hours. So not the most realistic example in terms of learning to drive standard, but our example nonetheless today. Okay, I will have to do this. What is your total displacement? What is your average speed? Okay, so my displacement I need to remember, okay, that refers to a vector quantity. Average speed refers to a scalar quantity where I need my distance total. So, in order to do A, as this is a vector quantity, I need to draw out all of my vectors. So say here, this is my start. So I go down south 165 meters. Now I don't need to draw this equivalent centimeters or anything. I'm just going to guesstimate and say this arrow represents 165 meters. And I'm also going to go over east 214 meters. Now draw in north, east, south, west to help give you kind of your references here. Now I'm going to draw my resultant vector. So this vector here, going from start to finish, F representing finish, this is my D total, my displacement total. All right, so to find out, and also I can say that this is my theta, because when I give my answer for this distance, or sorry, this displacement, I need to give it in reference to the angle That's its direction. Okay, I need to specify the direction because it is a vector. So to find out my actual magnitude of this vector, I can just use Pythagorean's theorem because I know my two sides. So a squared plus b squared is equal to c squared. The square root of a squared plus b squared is equal to c, which I know is my d. So I can put that in 165 meters squared plus 214 meters squared is equal to displacement. This totals to 270.22, etc. meters is my displacement. Now though, that's just only the magnitude of my vector. I need to find the direction of the vector. This is where I use my trigonometry to find out my theta. So I'm going to use tan because I know for sure that this is what I was given in my question. So I can say that tan theta is equal to opposite over adjacent. So I'm just going to rearrange this to solve for theta. So theta is equal to the inverse of tan times by opposite over adjacent. So to plug this in, so 214 meters divided by 165 meters. So theta then equals 52.36, etc. degrees. Okay, so now to put this into an answer. So this is my magnitude and this is my direction. Remember, our vectors need to be in magnitude and direction. So I can say, therefore, displacement is equal to, and this is to 3 sig digs, so I'm going to say 270 meters. Now I'm going to say this is 52.4 degrees, so I know that this theta now is 52.4 degrees. So it has gone 52.4 degrees east of south. So if I look here, say I started at south and I went 52.4 degrees, I went east. So I say in my answer, (270 meters), and then put a comma and say 52.4 degrees east of south. If you were to write this in a different form, you could go bracket S, 52.4 degrees, and then E. Okay? Or, if I was to reference how far east it had gone, or how far south of east, so if I wanted to measure this angle instead, because it is a smaller angle, so I'm going to say that's theta B. I could, and that would also be a correct answer. I'm having a hard time here. I think my alignment is a little off. So I will say, I could also say, or, that this is 270 meters, bracket, or comma, 37.6 degrees south of east, or E, 37.6 degrees south. So that's the first part of the question. That's A. The second part of the question asks us to find our average speed. So I know my V average is equal to D total over T total. So I just add up the actual distance I went. This is not displacement, this is distance. So this is 214 meters plus 165 meters divided by 7,200 seconds, because I put my hours into seconds. So I can kind of tell you how I did that here. So 2 hours times by how many seconds are in 1 hour, that gives me 7,200 seconds. Okay, so when I put that into my calculator, 0.00523 meters per second. That looks ugly, so I'm going to put it to 3 sig figs. So my V average is equal to 0.0, oops, I put an extra one here. I apologize. 0.526 meters per second. Or you could write it into scientific notation if you prefer. So that would be 5.26 times 10 to the power of -2 meters per second. Okay. Okay. So, now, another type of question. What do you do if your initial vectors of motion are not perpendicular to each other? What if one or more vectors are at an angle? To solve the two-dimensional problems where the initial vectors are not perpendicular, you must draw grid lines on each vector and break each vector into its x and y components. So this is really important, okay? Each vector into its x and y components. You need to put directions in yourself. South and west directions, we know, are usually negative, and north and east are usually positive. Don't draw your vectors tip to tail for this initial step, okay? So for this initial step. Then you add all the x components together and all the y components together. Then draw your x and your y vectors tip to tail to get a right angled triangle. Then you can use Pythagoras' theorem and our trig. So when we think about these two-dimensional problems, either they're going to be really straightforward, where it's just north and south and you can see everything, or it's going to be a different vector that's, say, going northeast, and you need to break it down into its individual components. So let's do an example. A dog ran 2 meters east and then turned and ran 4.7 meters, 38 degrees north of west. What is the dog's net displacement? So, let's draw this out. So, step 1. Step 1, red. Draw the grid lines on each vector and break each vector into its x and y components. Okay, so I know that my first vector is 2 meters east. Well, I don't need to break that down into 2 components, but because it's just one. Its component is only x. So x1, okay, is equal to positive 2.0 meters. Y1 is equal to 0 because the dog was only going east. It wasn't going north or south. So this is like 1, the first vector that we do. Now we can do the second vector that's a little bit more complicated. So with this one, he went 38 degrees north of west. So you need to start by drawing out your grid to kind of help you visualize what's happening here. So he went 38 degrees north of west. So I start at west, I go, just guessing, you don't have to use a protractor, 38 degrees, so theta is 38 degrees, okay? And the vector magnitude on that is 4.7 meters. So I know that my overall resultant vector is 4.7 meters. But now I need to break it down into its y component and its x component. Okay, so, or did I say that wrong? Yeah, this is x and this is y. So we're actually going to call this y2 and this is x2. All right, so let's do x first. So x2 is equal to cos theta. We can say as cos theta is equal to adjacent over hypotenuse. So adjacent over hypotenuse. Okay, so now I can put this in. So I know what my theta is. Theta is 38 degrees. This is equal to x2 divided by my hypotenuse, which I know is 4.7 meters. So to solve for x2, you can cross multiply. So now I have x2 is equal to negative 3.70365, etc. meters. Now my y2 is sine theta is equal to opposite over hypotenuse. So I can put that as sine 38 degrees is equal to y2 over 4.7, because that's my hypotenuse. Again, you can cross multiply to solve for y2. Y2 is positive 2.8936, etc. meters. Okay, so that was all step 1, breaking my vectors down into their individual components. Now I can do step 2. So x total and y total. So I now look at everything that I did going either east or west, and I add it all up. And then I took at everything I did north or south and I add it all up. So x total is x1 plus x2. That's equal to positive 2 meters plus negative 3.703 meters. This is equal to negative 1.70365 meters. Oh, and we know that this needs to be negative, also because it's going in a west direction, and we know that that direction is negative. So just in case anyone was wondering. Which makes sense that our overall x component is negative because our overall direction was a west direction. So our x should be negative because that's west. And then our y is y1 plus y2, which is 0 meters plus a positive 2.89, etc. meters. So obviously it's going to be positive 2.8936 meters. Okay, so that's step 2, looking at our x total and y total. Now we do step 3. So now we can draw all of our vectors together. So I'm going to draw, going over, here is my x total, and here is my y total. Now I can figure out from start to finish what is the resultant overall vector considering I did those two things. So I might just erase this S for start so that we're not confused. So north, east, south, west. We don't know this theta right now. We do, however, know our x and our y. So our x total here, we can say that's our negative 1.7, and I'm just going to go to 3 sig digs for now. And our y is positive 2.89 meters. Okay, so this is what I know about what happened. And this green line, this is my displacement net. This is what I'm trying to find out. So in order to find out that, that's my hypotenuse. So I can use Pythagorean's theorem. So a squared plus b squared equals c squared. To solve for c, it's the square root of a squared plus b squared. So negative 1.70365, etc. And include all of your digits because we haven't got to a final answer yet. So don't just skip all of these digits. Plus 2.8936, etc. squared equals c. Alright, so our displacement net is equal to 3.3578 meters. Okay, so now I know what the green line is. I know that this is equal to 3.3, let's go to 3 sig digs, oh wait, this is to 2 sig digs, so I'm going to go 3.4 meters. Okay, so that's the magnitude of my vector. But now I still need the direction. And the direction is given by my theta. Well, so I need to do step 4. So, step 4. So step 4 is to find that theta. So I know I'm going to use tan to find, because I have my opposite and my adjacent. You can use whatever you want because we have all three, but I just chose tan. So tan theta is equal to opposite over adjacent. So we are solving for theta. That's equal to tan inverse times by opposite over adjacent. So theta is equal to 59.51 degrees. Okay. Now I can write out my actual answer. So my actual answer to this question is D, displacement net, is equal to 3.4 meters, 60 degrees, because I'm going to 2 sig digs, so I'm rounding up, 60 degrees, and now how do I find my directions? Well, I went this, so if this is 60 degrees, I start at west, and I'm going up 60 degrees north. So this is 60 degrees north of west. So north of west. Or you could write it 30 degrees west of north. Either are correct and fine. So now what I want you to do is page 90, numbers 1 to 9. I'm going to try these myself, and if there's any issues with them, I'll just leave notes with the sub as to either which questions to omit or hints for questions. Then I'd like you to do your take-home quiz, which is due on Friday. If you have any questions or clarification about this content, I will be happy to answer any of them on Thursday, and we'll do a couple more questions on Thursday and give you some time for your take-home quiz. So hope you have a great day, and I'll see you tomorrow. Bye.